Okay, so you'll notice on this presentation, we're just going to go ahead and get right to rather than working through it here. Solve each equation with the quadratic formula. So this is something that is sort of like a quote-unquote last resort. The quadratic formula works with quadratic equations, obviously, because of the name. But this is the last thing we should do before we give up on the problem per se. Meaning, we've tried factoring the problem. We've tried completing the square with the problem. We've tried solving by square roots with the problem. All those things are much easier to use and do, but the last resort you can take is using the quadratic formula, which will work every time, but there's a lot of things that are in the quadratic formula. There's a lot of different steps and a lot of different letters that we use, and you can only use quadratic formula if the equation is in standard form, which this one is. This is standard form. Okay, so you're going to have to memorize this. Okay, and Mr. Schwann will sing you a song here to help you memorize it. But the quadratic formula is x equals negative b plus or minus the square root. Notice how it's super long. B squared minus 4 times a times c. All that's over 2a. Wow, that is a lot of stuff to remember. Now, there's a little song that I like to sing to help myself remember. Perhaps you've heard of the song, Pop Goes the Weasel. It sounds like, all around the cobbler's bench, the monkey chased the weasel, right? So there's that song. But you can do it with the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Right? That's such a good song. And, I mean, I could do a rap version if you want, but just for the sake of time in this video. Okay, you know what? So Beyonce also, yes, Beyonce, believe it or not, has the quadratic formula song, which sounds like x equals negative b plus or minus square root. You got the b squared minus 4ac, and then you put it all over 2a. Quadratic formula. Yeah, that's... Perhaps you've never heard that version before. So you have to memorize this. Essentially what I'm saying is you have to know what this is. And so make sure you write it down. And this is what you use. And literally all you do is you plug in A, B, and C to the correct spots. So for this problem that I have here on the screen, we know that A is... Well, it doesn't help that they use the variable b, but a is 2, right, because a is right there. It's the number in front of the squared term, so a is 2. B is negative 2, and c is negative 60. Okay, but Mr. Schwann, I bet you're saying, we can make this simpler. Can't I factor out a 2 from all these? Yes, that would make things a lot better for us, actually, if we factor out a 2. So if I factor out a 2, that would make it b squared minus b minus 30, which makes things a lot easier, okay? So now if we use this simpler one, a only equals 1, b equals negative 1, and c equals negative 30. So if you can simplify it, I would do that, so we're going to get rid of this guy. We could have used those numbers and it would still work, but if you can make it simpler on yourself, let's do it. Okay, so here we go. Now we're going to do the quadratic formula. So it's x equals negative, and b is negative 1, plus or minus the square root b squared, so negative 1 squared, minus 4 times a, which is 1, times c, which is negative 30, all over 2 times 1. Okay, so that's our problem right there. Let's go ahead and try to simplify this. Let's start inside the square root. Well, and of course, the negative, negative 1, these both become positive. So x equals 1 on the outside. Okay, here we go. Negative 1 squared is 1. And then, let's see, we have negative 4 times 1 is negative 4. And then negative 4 times negative 30 is positive 120. Okay. And then all over 2 times 1, which is 2. Okay, so inside we have 1 plus or minus the square root of 121 over 2, which actually the square root of 121 happens to be a perfect square. The square root of 121 equals 11. So sometimes when you're doing the quadratic formula and it works out to be a nice number, guess what that means? If you're able to take the square root of a number in the quadratic formula, that means we could have factored. That means we missed something and we could have factored this problem. But again, we didn't notice that. Let's just say we keep going. Okay. So I have two different problems here, right, because of the plus minus sign. So that means I have to write two different problems. So that means x equals 1 plus 11 over 2. I also have x equals 1 minus 11 over 2. Okay? Well, 1 plus 11 is 12. 12 over 2 equals 6. So one of my answers is 6. Over here, 11 or 1 minus 11 is negative 10. Negative 10 over 2 equals negative 5. So negative 5 is one of my answers. So those are my two answers using the quadratic formula. And again, so I want you to turn your attention back here to the square root. Okay? So for the square root, if it works out to be a nice number, guess what? That means we could have factored. But if you didn't recognize it, that's okay. And most of the time when you're at the point of the quadratic formula, you're going to notice that the square root doesn't work out nice. We do make that a decimal, okay? And this is only when you graph. So let's assume we were going to graph this. That's when you would make it a decimal, okay? So there's an example of the quadratic formula. Let me see if I can do one more here before we get out. And you'll notice it's not set equal to 0. Notice how there's an equals 12 here. Before I can do the quadratic formula, it has to be equal to 0. So I have to subtract 12 from both sides first, because it has to be equal to 0. So v squared minus v minus 132 equals 0. Okay? Because the equation has to equal 0 before I can do quadratic formula. And just so that I can remember what it is, let's write it up at the top here. Again, it's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Right? However you remember it, you got to make sure you know that. Okay. A for this problem is 1, b is negative 1, c is negative 132. Yikes. That's going to be big. Let's see if we can do it. All right, here we go. X equals negative 1 plus or minus the square root of b squared is negative 1 squared minus 4 times 1 times negative 132 all over 2 times 1. All right, here we go. So negative 1 becomes positive plus or minus the square root of negative 1 squared is positive 1. Negative 4 times 1 is negative 4. Negative 4 times negative 132. Wow, that's going to be big. It's going to be positive something. 8, 12, carry the 1, 528. Yeah, that's right. 528. Okay. So 528 all over 2. Okay. And then we have 1 plus or minus the square root of 529 all over 2. All right, so for this problem, 529 is not a perfect square. At least I don't think so. So I'm going to have to take the square root here. And again, decimals are okay, as long as I'm graphing. Usually if I wasn't graphing, that would actually be my answer. I wouldn't move it anymore. But because let's assume I'm graphing, I'm going to make a decimal here. So the square root of 529. Oh, it equals 23. Ah, Mr. Schwant, you should have known that was a perfect square. Sorry. All right, so it's actually x equals 1 plus or minus 23 all over 2, which means I can make two different equations for this problem. I have x equals 1 plus 23 over 2, and x equals 1 minus 23 over 2. All right, 1 plus 23 is 24. 24 over 2 equals 12. So 12 is one of my answers. And 1 minus 23 is negative 22 over 2, which equals negative 11. So what that tells me is, since the square root was a perfect square, that means I could have factored this problem at the very beginning. But sometimes it works out to be a decimal, and decimals are okay. And that's how we do the quadratic formula. So it's literally last resort, you wouldn't use quadratic formula, or if I specifically tell you to use it on a quiz or a test, this is how you do it.